Okay, if I said this, 2, 1, 3, I think I've pre-taught you enough to know that that would be a vector. That would go 2 in the I direction. Can you finish it? 1 in the J direction, and 3 in the K direction. And if I was going to show you that in this room, for people at home, you're not going to be able to see this, but you can imagine it. We have a X, Y, and Z axis set up down through the middle of the room, and I'm going 2 to the right, 2 feet to the right, 1 foot up, and then K is back towards you, another 2 feet that way. And that happens to be about the right length for this ruler. And there, I'm representing it by a ruler, and it's got a direction. It's heading that way. Okay, it's heading from 0, 0 towards that spot that it's heading towards. Now, just to clarify, it's not a dot. It is an arrow, and the length of that arrow is a big deal. And I haven't told you how to do this yet, but you can, in 3D, still figure out how long the arrow is. Back when it was in 2D, it was pretty easy. Like if we just went over 2 and up 1, then you could figure out the third side was what? Come on. Square root of what? 5. No, not the square root of 3. We got to do this squared and that squared, and that would be 4 plus 1 makes 5. Square root of 5. Does that make sense to you? All right. If you had it in 3D, anybody want to take a guess? It's kind of intuitive. Kind of like what Apple products were famous for. You don't even really have to think much. You can just kind of naturally do it. What do you think the third side of this three-dimensional triangle would be? Gonna take a shot at it? Square root of 14, and why are you doing that? What did you do? Come on, just tell them. You didn't just come up with 14 like out of nowhere. You did something. What'd you do? Can you interpret what he did? Squared them all and added them up. And then took the square root of that. So 9 and 1 and 4. And that adds up to 14. And yeah, it's the same exact process as before. You take the square root, except you square them all and add all 3 of them up. Okay, good. So that's how you'd find the what of this thing? Vectors have to have 2 things. What and what? Magnitude and direction. All right. The magnitude would be that, what we just figured out. Square root of 14. All right. Technically, I'm just pre-teaching you again. But today is one of those days where it would have been a long day if I hadn't already pre-taught this stuff. So, because you theoretically wouldn't have even learned what a column vector was. This was a column vector. This is called a position vector, just in case you've forgotten the words for them. And let's say I wanted to add a couple of vectors. It is as simple as it seems. 2, 1, 3 plus 5, 0, negative 2. Just take a guess what you think the answer is and write it down, please. A lot of vector stuff is really intuitive. It just makes logical sense. It's kind of like an extension of what you would have normally done, except into 3D. Did you have 7, 1, and 1? Then I can tell you what the answer looks like in class. If I move 7 to the right, and then up 1, and then back 1, there'd be a dot right about here, and it would be an arrow that starts at 0, 0 and goes to that dot. Okay, that's a vector. All right, what do you think would happen if I put a 2 here? Yes. It would multiply all the values by 2. Yes, just like you would expect it to. All very intuitive. Okay. Now, it wouldn't be 7 up here anymore. It would be what? 9. What's the next one going to be? 2. And what's the last one going to be? 3 times 2 is 6. Minus 2 is 4. That is called a scalar, also known as a scale factor. I just scaled it up. And guess how long the vector gets if you double all of its components? It gets twice as long. I'll give you an example in 2D that I think it makes sense to you. Would you agree there's such a thing as a 3, 4, 5 triangle? if I double this and I double this, now some of you are like, like spidey senses are going off like, maybe it's not just double. No, it is. It's just double. You double them all. If you double them all, the proportions will stay the same. So the length of, or the magnitude of this vector would have been 5. Put arrows on both ends, not a good idea. There we go. That vector would have a magnitude 5. If I doubled its over and I doubled its up, then yeah, it would double how the magnitude of that vector would be. So it also happens in 3D, same thing. If I double all the dimensions, then the thing's twice as long. Okay, yay. We're covering a lot of ground pretty fast. So, I know this one gets people all the time. This is AY. And then I go from Y to P would be called YP. And that's AY plus YP. Sometimes the simple things are what get people. What's the answer to this? AYP? No such thing. What is it? AP. And could I just go like this and like go home back to where I started from? No. It's got to be the other way. So it's like this. So it's AP, not PA. Okay, how about if I did this? What if I said, what's AY minus YP? Now just to clarify, technically you can't subtract vectors. I know you're like, what? We've been subtracting them like all the time. You can add the opposite of the vector. I mean the opposite of the vector. If you take the opposite of the vector, do you think it gets like, what does that change? Its direction or its magnitude if you do the opposite of it? Direction. So then, I hope you in your head are thinking, oh, so then I just go like this. Because that's the opposite of the red one. And my answer then becomes this guy. I will put it in black since I haven't used black up here yet. There'd be my answer. Okay? So when you're subtracting a vector, it's like you're adding the opposite of the vector. The green one was the opposite of the red one. Okay. So because I pre-taught how to do column vectors and stuff, this is going to be pretty easy. And we're almost ready to start your homework. And then we do have time to grade the lab today. Yay. Yes? Good question. If I was going to call this anything, I would not call it P. You know why? Because P is supposed to be here. You know what I mean? Sometimes if we want to make something like, kind of like P, but different than P, we could call it P sub 1 or P sub 2, as in a subscript. Or we could call it P with a little dash like that, like P prime. That's a way to make it like, I know they're related, but they are different. Okay. All right. So I'm going to pause for a second while we pull up your worksheet for homework. That fast. Okay, find this page. This is your assignment. It's on the 19.1, day 3. If you're looking on Schoology, it's on today's date, which is May 15. Pausing for a second. Okay, bye now. Everybody should be here. And looking at the first one, why did I write the blue writing there? I just wanted to show you that I plus 7j minus k is the same thing as 1, 7, negative 1. So if they want me to do 3b, that means I got to grab this one, and I got to write it as 4, 7, 5, but then 3 of it, it's just like that. So don't overthink these. These are not that rough. You're going to times those together. And what is the answer? Well, the answer is going to be 12, 21, 15. All right. And I'm just showing you that these position vectors can be written like these, which are column vectors. All right. This one, you're going to double the A and then subtract the B, or as I told you before, add the opposite of B. So what's the opposite of B? You just make everything go in the opposite direction. B is 4, 7, 5. What's the opposite of B? Negative 4, negative 7, negative 5. So if you want to think of this as 2 times the A, that's fine and easy. This, I'm just trying to say you can either subtract B But technically, I just want you to know, in a picture especially, this helps it. You just want it to go the opposite direction, and then you add the vector. So I could go like this and then distribute the negative. So either one works. Okay? All right. You'll see I scribbled out under number 2 so that you only have one of the two of those to do. And I reminded you that this is the little symbol we should be using for vector, but with the blue line there above the OA. But they have a full arrow on there because just we don't have that font. So, or that equation editor isn't quite good enough. All right, so that's it for that page. Go on to this page. We are skipping the top of this page, but doing problem number 4. It's got 2 coordinates, and you're trying to figure out what that vector is. Don't forget, let's say it ends up being like this. Do you get you can move this to like here? Come on, move. Trying to drag that down. It won't let me drag it. Come on, move. Won't let me move it. I was trying to drag that down so that its tail would be at 0, 0. That's my point, is that when you're done with this little thing, don't forget that you really want that vector to be starting at 0, 0 so you can kind of know what it should be called as a column vector. Otherwise, you have to count these, and you have to count these, and it'll still work. But, all right, moving on. This one's a good one. It uses words, and sometimes people get all scared that that's going to be like really hard. Don't. You need to be able to realize that's just another question that's a lot like the others. It's just describing it in words. Number 6, you may skip. Cross that one out. Nothing wrong with that problem. You could absolutely do it on a review day. Number 8, good problem. They're saying they multiplied by something like a 2 right there, but they're not telling me what. Okay, you got to figure out what they multiplied by there. And then they got another little b over here that they multiply by. But when it's all done, it made this. So you should be able to, you can either make this more complicated and set up equations for it, or just kind of think it through and go, what number would have to be in the A spot and in the B spot to make the answer that? It's a good question. Okay, number 9, notice how I wrote in a 2 and a 3. Those are not a 2 and not a 3. But they're asking for what numbers could you multiply in front of the A matrix and in front of the B matrix. These are called scalars. They're not 2 and 3. You figure out what they should be to make it equal this. Okay. And on to this page where we've got a reason I wanted to do this one especially. It is actually a situation, and in the real world they actually used vectors for the first time when they were talking about submarines. They would, like on a map, they wanted to be able to say this guy's going in this direction at this speed, and that would be a vector would be a good way to say that. The arrow would kind of show the direction he's going, and then the speed, and then they started making a branch of math around that. So believe it or not, vectors aren't incredibly old. At least according to our information, a submarine was one of the first times when vectors got used. All right, and that's it. And again, I had just skipped part C, not because it's a bad part of the question. I'm just trying to keep the assignment size down to a reasonable amount that you could actually do. So please keep doing your homework. You have much more time than usual to work today. So let's use it well. If you need help, walk up and ask. And in a moment, we are going to be grading the lab. For anybody who missed that opportunity, if you're listening at home, you can email it to me if you were absent today, and I will grade your lab for you. All right. So that's all I got for that.